Hello and welcome to Numeristical. Making a quick video today because I wanted to talk about a really interesting phenomenon that occurs during the NFL playoffs, and it was really brought to light this weekend when we had the first round of the NFL playoffs. And specifically what I'm talking about is the game between the 4 seed and the 5 seed. And if you look at it this year, and if you look at it in previous years, you'll see that it's often the case that the 5 seed is actually considered to be the stronger team. So in both games this weekend, the 5 seed was actually the favorite, despite the fact that the game was hosted by the 4 seed. So the 4 seed had home field advantage, but the 5 seed actually was considered the favorite in both the games. And we're going to show that there's actually a mathematical reason why this is often going to be the case. So let's dive right into it. So if we look at the standings this year for the AFC, you'll see that we had the Cleveland Browns were the best wildcard team with an 11-6 record, and they got the 5 seed. And the Houston Texans were the 4 seed, and they had only a 10-7 record. So the 5 seed actually had a better record than the 4 seed. And as we noted, the Browns were actually favored in their game against the Texans, despite the fact that they did, in fact, lose it. And if we look at the NFC, a very similar thing happened. The Eagles were the best wildcard team at 11-6, and the Tampa Bay Buccaneers were only 9-8, yet still won their division. So if we look back a season ago, we'll see a similar thing happen. In the AFC, we had the Jaguars winning the AFC South with only a 9-8 record, yet both the Ravens and the Chargers had a 10-7 record and were considered to be better teams. And in the NFC, we had the Buccaneers at 8-9, won their division, and clearly the Cowboys at 12-5 were considered to be a much better team. And if you look back over the years since the NFL adopted the 6 or 7 team format with the 4 divisions, you'll see that this actually happens a fair amount of the time. And the question I always thought about was, why is this the case? Is there a mathematical reason for this? And it turns out there is, and that's what I'm going to talk about next. So how should we think about this problem mathematically? So what we want to do is imagine a situation where we've got the teams ranked from best to worst. So 1 is going to be the best team, 2 the second best team, and so forth, down to 16 being the worst team in each conference. And we're going to imagine that we randomly assign these 16 teams into 4 divisions of 4. And the way we can do that is by thinking about these 16 slots, 4 slots in each of the 4 divisions. And we're going to randomly assign the first team to one of the 16 slots, and then randomly assign the second best team to one of the 15 remaining slots, and so forth. And let's do a couple of examples of how this might play out. So let's say I take the first team and I randomly assign them somewhere, and they end up in the AFC North. Now I take the second team, assign them randomly, they end up in the AFC East. Now let's say I assign the third team randomly, let's say they also end up in the AFC North. And then let's say the fourth team ends up in the West, and the fifth team ends up in the East, and the sixth team ends up in the South, and so on. Now here you'll see a situation where, assuming the teams play to their potential, that this wild card team, the second best team in the AFC North, is actually going to be better than the best team in the AFC South. So this would be a situation where you would expect that the wild card, the best wild card, is going to be better than the worst division winner. So that's only one way these things could have worked out. But let's think about another scenario. What would have to happen for that not to be the case? For that not to be the case, you would need the 4 division winners to be the top 4 teams, which would mean those top 4 teams would all have to end up in different divisions. So, for example, you'd need to have the first team if they ended up in the North, and the second team end up in the East. Then you need the third team to end up in either the West or the South. And then if they end up in the South, you need the fourth team to end up in the West. And then it doesn't matter how you fill in the rest of the teams. You know that the worst division winner is going to be better than any of the wildcards. So let's think about how likely is this to happen. So when we assign the first team, there's no possibility of anything going wrong. Let's say we want the four top teams to end up in 4 different divisions. So when we place the first team, it's not going to ruin anything. Doesn't matter which division they end up in. When we place the second team, we're okay as long as they don't end up in the same division as the first team, right? So what's the probability that they end up in a different division than the first team? Well, there's 15 remaining slots, and 12 of them are in divisions other than the first team, and only 3 of them give us a problem. So the probability is 12 out of 15 that will be okay. So let's say that works out. 2 ends up in the East. Now we're placing the third team. What's the probability that, again, we don't have this problem? Well, there's 4 spots in the West, 4 spots in the South, and 3 left each in the North and the East. So the probability that they end up not colliding with either of the first 2 teams is 8 out of 14. So let's say that works out. They end up in the South. Now for the fourth team, they can't be in the East or the North or the South. They have to end up in the West. And there's 4 places available in the West, but there's 9 in the East, North, and South. So you see now it's gotten really hard to make sure those teams don't collide with one another. So in this last step, the probability of the 4th place team ending up in a division apart from the other 3 is only 4 out of 13. So let's put that all together and say, what's the probability that this situation happens, that the 4 best teams end up in 4 separate divisions? And we'll see that, well, when we place the first team, it's probability 1, there's no problem. For the second team, it's 12 out of 15. For the third team, assuming it worked out so far, it's going to be 8 out of 14. And for the fourth team, it's going to be only 4 out of 13. So if you multiply all those probabilities together, you get 14%. So there's only a 14% chance, if we were to sort of assign these teams randomly, that the top 4 teams would end up in 4 different divisions. And I think this is really the reason why you see this happening so much, that the best wild card is actually better than the worst division winner. It's really just the simple mathematics that it's quite unlikely that the 4 best teams will end up in 4 separate divisions. So anyway, I hope you enjoyed that. I found it really interesting. This is something that I thought about a long time ago, actually, and I just thought I'd share it now that it's relevant with the NFL playoffs going on. Funnily enough, as it turned out, although both the Browns and the Eagles were respectively favored against the Texans and the Buccaneers, it turned out that both teams lost. So, you know, there's always a bit of randomness and everything. But I still think it's very interesting to think through and to have a good reason for why we expect the 5 seeds to generally be better teams than the 4 seeds. So I hope you enjoyed that. It's January and New Year. I'm hoping to really get a lot more content out this year. So I hope you'll like this video and subscribe to the channel and keep watching it and stay tuned for more content to come. Have a great day.